Good afternoon, everyone. I'm George from infrastructure team of openEuler community. Glad to be here to share with you the development of openEuler and how openEuler started to be a developer-friendly community. The topic of my speech today. Okay, I will introduce you from the following four aspects. Our team overview, cloud native DevOps, cloud native application design, and future plans. First of all, the infrastructure team overview. The infrastructure team is one of the earliest teams built in the community. After 4 years of the development, we have established 5 special interesting groups. They are Infrastructure SIG, Gatekeeper SIG, CI/CD SIG, Open Design SIG, and the Reproducible Build SIG. Our team members has grown from 5 to nearly 20. The scope of our work is also expanding. We are mainly responsible for the community development process, such as code hosting, the pull request check, package building, and software signature. We also support the community operations, such as community website, member management, meeting management, and email service, and the data dashboard. So we are going to talk about the infrastructure net scope, and you can look at this picture. As you know, openEuler is a completely open source community. So when we build our own infrastructure, most of the services are developed from open source projects of the well-known community. Take a look at this one. Take a look at this one, GNU Mailman. Maybe you have used it before, which we use it as our mail list service. We also use Jenkins to build CI pipeline and OBS from OpenSUSE to build and distribute our packages. You may also find a bunch of projects from the CNCF. Yes, we have the Nginx Ingress, which is used as our reverse proxy server and as a simple API gateway. Argo CD is also used to centralize our applications, the changes, and code into our production environment. We also use a Vault from HashiCorp as our sensitive data background, as well as Corpora. Corpora is from Fedora. And we have enhanced the Corpora in several ways to make it running better in a corporate cluster. Lots of projects. This part, I will give you the overview of infrastructure architecture. Actually, there are 2 tiers in our infrastructure. For the first tier, we use Terraform files to centralize and to create all the basic IaaS resources, includes the VPC, database, storage device, the virtual machine, and the physical machines. For the second tier, here is all about the corporate clusters. We have master cluster to run key components, and the worker cluster to run different applications in different regions and different clouds. Now, we have 160 services, 6 Kubernetes clusters, and more than 300 virtual machines to support nearly 20,000 developers in openEuler community. It's a huge infrastructure. Okay, we are going to the next part. It's about cloud native DevOps. I will share some experiments and some best practice with you on how we deploy application in the cloud native way. There are 4 parts. The first part is about deployment standardization. Most infrastructure services of the openEuler community are deployed on the Kubernetes cluster, so services need to be containerized. Containerization brings us many benefits, such as easy migration between different clouds, easy tracking of every deployment change, and reduced deployment time and application recovery time. So we have made some efforts in standardization. Containerize application, change log outputs, manage image repository, and health check. The second part is about configuration separation. Yes, in the whole service deployment process, we divided different responsibilities by application developer, DevOps engineer, and infrastructure maintainer. Yeah, application developer are only responsible for service deployment and container constructions. DevOps engineer are responsible for service resource interconnection, such as ingress and database configuration. Infrastructure maintainers are responsible for service release and use Argo CD to centralize services on IaaS resources. Okay, the part 3 and part 4 is about GitOps and automation. Part 3, we use Git repositories to store configuration files and to centralize with Argo CD while deploying infrastructure services. In this way, services can be quickly brought online, historic versions can be managed, and service reliability and security can be further improved. The last part is about automation. Actually, there are 3 different cases. Take a look at this one. This picture shows from pull request submission to website preview, from code merges to Jenkins build and publish, from new configuration files to service cache clearing, and to notification. All steps are automated. Okay, we are going to the next part. During this part, I will share some useful applications that we have been working on to make them better running in the Kubernetes cluster. The first one is about bots. So if you guys have ever been in the open source communities, you must have learned that there is a bot application used to collect all the different applications into the pull request. For example, if the developer submits a new PR, the maintainers will use the bot application to check the commit to perform the CLA check, as well as sign or unsign a PR for someone and post comments on the pull request. Our bot application is named Yabert, which is based on the idea of Pro project from CNCF, and we proved it through several aspects. The first is robust. It means each single plugins will be separated in the container, and it's easy to replicate it. If one of the plugins crashes, it does not affect the whole application. Yeah. The second improvement is about the highest throughput. Yes, we use Kafka to receive the message from the code platform as well as the delivers. And other improvements focus on multiple platform support and multiple developing language support. The second application is the meeting bot. Yes, have meeting is an essential requirement in the community. As we have about 10 meetings per week, so we have created our own version of meeting bot. Our meeting bot supports multiple meeting platforms such as Room, WeLink, and Tencent. And you can book meeting via website or WeChat app, rewatch the meeting video via YouTube or Bilibili. Actually, the architecture of the meeting board is quite simple, and most of the job is done by Kubernetes. Once the meeting event comes, we will use Kubernetes to create a meeting, to send the email to our maintainer, to down our meeting videos, as well as publish it to social platform. Okay, we are going to talk about the Signatrust. Signatrust is a project based on the idea of OBS sign from OpenSUSE, while provide a more comprehensive and efficient and cloud-native solution for package sign. It's end-to-end security design with high throughput. It can support almost all binary files. And has a user-friendly key management. The next app is MOOC Studio. MOOC Studio is based on Kubernetes operator and provides an openEuler terminal environment for community developers, especially for developers comes from university or high school. It's a common case that there are some troubles to get the real environment. So especially for the Arc environment to run the operation system. In order to solve this problem, we have developed our MOOC Studio. MOOC Studio is a kind of native terminal playground in a browser. It has some good points. First, we can establish collection to brand new environment in only 20 seconds. Second, it supports multiple environments such as application container, system container, or virtual machine. Third, the environments can be quite highly customized, include base OS, architecture, or additional files. The last one is the environment will be released when disconnected. This part is about EUR. EUR is short for openEuler User Repository. Actually, it's based on Corpora project from Fedora, but the components has been customized for openEuler. First of all the components has been upgraded for Kubernetes environment. And we use serverless Kubernetes port as a backend package builder. Second, it can reserve package dependency and auto import. And EUR is highly integrated into our package developer process. Okay, this part we're going to talk about our future plans. The first one is software marketing. We will do our efforts to provide a convenient platform for community developers to query and to obtain software. Second one is the Cloud IDE. We will support developer and test process with Cloud IDE. Third one is Message Center. We will integrate all application with Message Center by Cloud Event. Okay, you can scan the QR codes and visit the website here to join us. Okay, thank you everyone.